come on, you. Be stuck on my lapel. There we go. I guess that's enough volume. Maybe I need a little more. There we go. Hello. Anybody who's dialing in to presumably the playback, because nobody showed up to the live thing yet, because it only just went on. Chris from Airwindows doing a coding stream, somewhat inhibited by the fact that my Blackmagic software is not working properly today. I can launch it. I can switch to the camera control, but it doesn't do anything. So the software is busted at the moment. Wonder whether the thingy is busted. Nope, that's still alive. Which makes it problematic because I kind of need to do the picture-in-picture that I usually do. I guess we'll see whether that lives or not. Is it the camera itself that is broken, or maybe some connection to the lens? Or are we not able to talk to the switcher at all? And shuffling stuff around, let's test that assumption. This is kind of the hacker world. Everything's broken all the time. Do it anyway. This often seems to be the world as we know it. So, hi. You're not supposed to be black. You're supposed to be a functioning input. Let's jerk around with that a little bit more. Maybe it needs to be plugged in. There we go. Yeah, it's coming to life. Yay. Now, again, you see, somebody's here. Now I try to run the macro that will give me the picture-in-picture. Okay, that part worked. Oh, and now it's able to talk to the camera. Hi. Technical issues, as always. This is the world in which we live. Again, like I said, it's kind of the way of it. Everything's broken all the time, always. Zoom in a little bit closer, and we don't need ATEM software control anymore. Although I could do silly things with the picture-in-picture or the screen, but we're not going to deal with that right now. What I do need to do, however, is get chat in there. Absolutely ask an off-coding question. And let me get that on screen. Firstly, seeing as I want to have chat visibly. Don't mind me. Endless series of things to do to get everything working. I'm pleased that I got the ATEM Blackmagic software working, though. I'm not sure why it wasn't. Something was wrong. Bim. There we go. So, why are most bigger names of studio monitors using Class AB amps? I can give you the simple answer for that, which is probably just as well. Class AB amps produce a lot more power than Class A more efficiently. See, the way that works is Class A has to be consuming all of the power at all times, and you're just sort of modulating it. It gives you a cleaner output in terms of no crossover point at 0, because Class A doesn't do a push-pull configuration. It's one-sided. It'll also generate more second harmonic distortion, and that could also be part of it. You don't necessarily want euphonic, like warm second harmonic coloration if you're doing critical listening. So class AB is going to be balanced in the way that class A is not, although I don't think it's not necessarily a given that you can't have push-pull class A operation. You could have that. It would just be equally inefficient. And as far as class D, well, heck, I use class D. And if you're talking about studio monitors, active powered monitors, I think a fair amount of them will actually be using class D. But yeah, the reason that people use class AB is for high power output and lack of even harmonic distortion, because that's something that you'll certainly get out of class A amplification. Today we're drinking Celestial Seasonings Tension Tamer tea, which is quite delicious. I generally have that for breakfast, and I only just barely finished breakfast, so we'll move on and start doing coding type stuff. I hope people have been enjoying the ultrasonic thing. That's what I was doing last week, and I ended up just making it into a elaborate stacked up biquad filter thing in order to get the steepness of filter cutoff that I needed. And yeah, like I said in the post, the reason that is not running inside an instance of console is because, first of all, console has a nonlinearity, so it kind of defeats the purpose. But also, running the EQ inside console makes it start to become more like your analog style of EQ. It's got gain stages in it, you could overdrive it, stuff like that. And that's not necessarily by design. It's not that it's designed to distort nicely or something, but the upshot of running a console system is that there will be a headroom to it. It will run out of steam at a certain point. And I thought that the Ultrasonic plugin would be better without that. So yeah, let's scooch around with my little controls and let's have a quick listen to an audio track to check that this is working. Yep. So we'll be able to test our matrix reverbs. So plugin video for a name I don't remember. I need to make a plugin called that now. You understand that, right? I need to make a plugin called name I don't remember. That'd be great. But class AB distortion, yeah, the reason you're not remembering it is because it's named after a different process. That is the single-ended triode plugin. So it's 3 words rather than 4, but the description of the plugin is not actually the one you're trying to remember. And it does create, it creates a variation on class B distortion. What it's doing is, like literal class B distortion, is blatant discontinuity in the middle of the wave. Whereas what I was doing with the AB slider on single-ended triode is sort of make a little curve into the discontinuity. So it's still a discontinuity, but it's not as aggressive. I could actually even demonstrate that. Seeing as we're talking about it, I can show you what it does because I can run it on a wave. Assuming I have it installed, which I'm pretty sure I do. Let's find out. I think I have everything on here. A single-ended triode. Do we have? Yes, we do. So you can't really hear that because it's a bass note, but doing a single-ended triode, we're getting a second harmonic And that's a high enough note that you can kind of hear it over these little speakers. Whereas Class B, immediately you start hearing it. And if I was to apply that, turn it way up, you can see that what it's doing is basically sort of offsetting. I could do it in the opposite direction. The current one doesn't do that. But you could offset it so that it amplified, and then the middle would be a tick of high energy rather than a not switching into the sine early enough. Basically, I'm squishing the sine together and cropping it at 0. So we'll undo that, and then going back into there, if I do the class AB, and we apply that, it's less easy to see, but you can kind of see that there is I think it's, what's going on there is it's flat and the edges are curving into the sine more than they would on the Class B. But these are not essentially modelings of any given amplifier that happens to be Class AB. They're what I often do, which is a way of manipulating the waveform and associating with some kind of sound that seems useful. So yeah, let's jump back into this. Remember, the first time I did this, it took an hour to get an output out of it. Sometimes this is slow and tedious work. Switching at 0 is not Class A. Class A is going to be single-ended triode, and I could even go back and demonstrate that too. I demonstrated the other stuff, and I showed that you could hear, or maybe you could, maybe you couldn't, because the silly little speaker I have isn't really putting across much audio. But I can literally show you what it looks like. We're making it so that, like this, turns to this. Well, that is a form of distortion. We've actually clipped the heck out of it this way, so I might need to chill it out to show more accurately what it's like. Trying to put my mic back, don't mind me. Yeah, so you can see how this is second harmonic distortion, but it's also a little aggressive. I think it's just pushing too hard. So let's take that back out and do it over. I can watch that meter and see at what point do I start taking it down a lot. If I apply this, now you can see that it is doing a very obvious second harmonic clip. This is essentially a sine-based clip that is offset in such a way that it's going to full clipping over here. We could even do a, there's a Eurorack type processor that does this. And cone filter is not the right word, where it uses the sine functionality to wrap around, and it's like a frequency multiplier, but not, because it's more complicated. We can make it so that, here, let's see where this pointer goes. We could make it so that in the process of clipping this flat, it could also start curving in, because that's one of the things that the sine algorithm can do for us, or even going to the inverse. And it's something that we have on the O-Coast synthesizer, for instance, wavefolding. That's what we're talking about, wavefolding. So this is coded in such a way that it clips at maximum sine clipping. But if you're using that algorithm, then you can make it wrap through so that it goes inverse, and the more you push that, the more intensely it'll start doing a massive wavefolding behavior. But yeah, right now that wasn't on the agenda. But yeah, a lot of people are talking about aliasing, and when people kept talking about, I don't know, isn't it the Tokyo Dawn ultrasonic filter? And I was like, that's a really useful kind of utility filter, and I'm all about utility filters. I should have one of those in my little arsenal as well. There's no reason I can't have one of those, and I make them with no GUIs and no controls and things, so I can probably make one that's more CPU efficient. I'm not sure that's true, but I think there's a fair chance, because like what I trade off in terms of not running the interface, I also lose in terms of running the calculation at a much higher accuracy. So you give from one hand and get from the other. It'd probably work out fine. In any case, if people are fond of having Airwindows plugins, especially the ones that don't have interfaces, so you just put them there and you're like, okay, we're done. I'm definitely capable of putting something like that out, and so that's what I did. It's also kind of striking that I modeled it on the that track that I'm always using, in which I reproduced a analog mix and threw some stuff into that mix reproduction. If I had had Ultrasonic at the time, I probably would have included it. In fact, I threw it into the starter kit. The starter kit now has the Ultrasonic plugin in there and a line describing what it is and how to use it. Because it's simple, it doesn't require much fussiness, you can't really hurt anything with it. And I feel like approaching the plugins from this minimalist thing where it's like, what's the minimum I need to do to get a really striking kind of Airwindows style mix that I might want? It fits in well with that. It's comprehensible what one does with it. I'm also noticing that I could probably get away with compressing this video more. Heavy distortion sounding more like a Tesla coil. I do have a Tesla coil plugin, but the sound of a Tesla coil is indeed a huge mess. So I'm not really sure where you're going with that. But yeah, I need more of a description on that one because I don't understand what you're up after. Let's see now. And slew limiter on the sidechain of a comp. Yeah, you know, most of my compressors already use that functionality, but in a different way. Oh. You're using your culture volt. Fair enough. I don't make that one, so obviously I don't understand how it works. Hey, Andy. So, firstly, quick build. Here we are. Matrix Verb is back in action. We're going to see what we can make happen. I'm definitely more than a little interested. I'm doing all right. I'm feeling a little under the weather, but I never really got over getting sick in March, and maybe that's just a thing. It might just be a thing that I have to get used to. In any case, I can take things easy, and I'm certainly holding up in my place, so I feel comfortable going into winter. Also, I have some extensions of my plans in mind. This is what we did last week. We were doing vibratos, and that's a pitch shift. So with this, we're fooling with the matrix verb and its way of doing stuff where it can make a continuous reverby kind of wash with only 4 delay taps because they're all feeding back into each other. No amp business today. Hey, Lorenzo. However, one thing I can show you is this. Microphone stand business. See this is among the wire work that I'm doing. I've got more on the way. I'm getting large quantities of wire. Oh, also, and here, let me get this lint off of my hand, switch back to this camera. So yeah, even though I am completely covered with lint now, I am doing this in the direction of moving towards being able to set people up with parts. This is the cable that I'm going to be giving people when they're ready to get going with this stuff. It is 22 gauge solid core. It's exactly the kind that you get out of all electronics if you buy that. And I am purchasing 18 miles of the stuff so that I can have it at such a cheap cost per foot that I can just straight up give it away. I'll be giving it away by the furlong. Well, not the furlong, the fathom. Furlong would be much longer, actually. This is 1 fathom of wire. A fathom is a unit of measurement which is roughly the extent of a man's outstretched arms, or roughly 6 feet. It's just a hair over 6 feet. I'll be able to afford, in fact, I already could, send anybody who wants 10 fathoms of wire of different colors, unless you wanted like not to have all the colors or something, or particular kinds. It wouldn't really matter. Like you could be like, I want 10 fathoms of nothing but yellow, and it wouldn't pose a problem once I get the colors of wire in. And this is what you'd be using to make connections between different places in your synthesizer. And let me see, let's not break the wire. And this is what you'd be using for your blinky lights. This, I cannot frame myself very well, don't mind that. This is a large collection of LEDs. How large, you may say? The word over 9,000 is indeed quite appropriate. So basically, when I'm ready to set people up with synthesizers and things, what I can do is just get a handful and give people more LEDs than they will technically need to do any given thing. This is how this stuff works. If you want to do a thing, it helps to be able to buy it. Yeah, that is it. The meme is accurate. That is literally over 9,000 LEDs. And you shouldn't need more than, I don't know, 50, 100 to start it up with some basic stuff. And it is still possible to purchase things like LEDs and chips and stuff yourself. But my intention there is to be able to get people going who don't have that stuff to start off with. And there's another thing. Down here, let me make this hide for the moment. I've been talking about, hang on. There I am. I've been talking about making these things. I have pretty much all the information to get going and start wiring up little stuff that would be cool and interesting. That's certainly my intention. I use a reference of a guy out there who's doing this kind of stuff and kind of handcrafting synthesizers out of it. His name is Peter Blasser, and he does the line of synths called Seat Lombard. And Seat Lombard is very interesting because it's really a artwork. They're handmade things, and they're really quite expensive. They're not terribly accessible. Even if you had the money for them, you'd have to get them in some way, and they sell out. And it's not necessarily easy to deal with this fellow. But the way that works is that fellow is able to make these kind of synthesizer artworks and popularize them to some extent, although you have to be relatively wealthy to get in. I think that he has workshops where if you have physical accessibility to where he's doing this stuff and can't afford to buy one that he hand built, he'll bring a bunch of parts and do a workshop, and you can buy attendance to the workshop and sort of build your own. But that can be even more difficult if you don't live in the country he's in or whatever. So one of the things about Peter Blasser is that he makes these PC boards, these very creative, unusual PC boards, where it's circuits all laid out in this weird, like line art sort of way, or arranged in a pentagonal configuration. It's very artistic. And there are some really interesting things about how he's doing it, which relate to circuit constants and how a printed circuit would sound. He's basically, through the doing traces as lines, rather than doing traces as the computer figures out where to run it and what to run it through, he's doing some things with these circuit constants that have tonal effects that are advantageous, and that's part of the reason that his synthesizers sound interesting. And he designs them on a program that I have, and that is freely available, and that you can have too, and that runs on this laptop that I can stream coding with. So that's pretty exciting. Essentially, what we can do is use this to kind of lay out parts and things. It's not answering what I'm trying to do. That's a little better. That's not better at all. I'll sort this stuff out eventually. So right now, I haven't got a clue as to how to work this stuff. It's very interesting, and I have enough instructions that I know how you would go about doing this kind of thing. I don't at all remember how you go about doing stuff like I don't know what that icon means. Oh, I just found out, didn't I? It flipped. And there's bound to be things like drawing a printed circuit trace, but that wasn't it. Maybe this is it. And it'd be drawing traces around and connecting them to stuff. I doubt that's it though. But we may end up spending time doing things like working out how to lay out circuit boards, which would be handy because the whole solder core thing I'm moving towards is largely not having to do this. It's hardwiring stuff with literal physical wire. Also been called dead bug prototyping. But if you can do these things, and I've been looking into it, I found the place where he has his circuit boards made, and I found some advice as far as how you take stuff in Osmond, which this is, and format it for Gerber output files in such a way that you could get a result and actually send it off and have it made into a PC board that worked as you specified it. You see, here's a scissors for cutting stuff. What is this? Swap signals between pins. Attach a trace. Select a signal. Maybe this was the one I was thinking of. Nope, that's not actually a signal. What if I do this? Aha! Okay, interesting but unhelpful. Right hit objects, set origin, trace bend. Does that mean I can bend this? I think maybe this is just a crude diagram. I'm not seeing any actual traces. I have to learn how this works before I can do anything with it. We're not going any further here with this today. I'm clearly not going to be able to learn this on stream while people watch. I don't think it does run a simulation, no. You kind of have to know what you're doing. With some of these stuff, it's fairly easy. Like one of the things I'm doing, this is also on my chore list. I need to take these data sheets and translate them to these drawings with drawings of the pins arranged like this. This is a 8-pin and a 9-pin spacing on each of these, so I'm going to have to draw those out as well. And basically draw out what these various chips do. At which point, working from the picture, you can start wiring stuff together. So we don't necessarily have to do computer-aided simulations. A lot of this stuff is a little more approachable than that, but you do have to get started and actually start doing it. And I have a lot of like reference drawings and things to do first before we have that going. It's not really terribly close to being going. But yeah, this is why I'm doing all of this stuff. The amount, having one person doing all of this while also doing Airwindows on a weekly basis is a bit of a huge deal, and so I'm usually not getting anywhere with it, but I'm getting as far as I can. That is the limit of as far as I can get. And often it's not too bad. But the whole idea with the solder core stuff is that this is how I started out. And I would like to be able to let other people do that as well. And I see much potential in it. So it's been a process of just getting together all of these things. Like once I have this stuff sorted out, not only will I be able to start wiring something together, and probably it'll run faster than these coding streams. Maybe, hopefully, hard to say. I'll also have worked out all of the production issues around being able to conveniently go and get appropriate boxes and get appropriate shipping arrangements and be able to throw like dozens of piles of wires and LEDs and things into appropriate boxes and send them out relatively easily, so it doesn't take me all afternoon to get together like one box of stuff, or stop me because I don't have the parts necessary or something like that. Instead, I will have all the parts necessary in such massive quantities that I can totally spare them. And that's when that'll start moving. So as far as soldering iron and specs, well, I'll have to show people how to solder. That'll be on my YouTube channel and probably linked to from the web page. There'll be a special link to, this is the video that shows you how to solder. And specs is strongly inspired by the Eurorack world. Specs is, this is how you make an oscillator. Here's how you might wire some of these together. Let's see what happens when you wire this oscillator into the frequency modulation of that oscillator, into the frequency modulation of that oscillator in a loop, you know. That's not a spec, that's a patch. It's going to be a world of patches. A world where all these wires, the like 10 different colors of wire like this, and it's about 6 foot long. And when you have your little collection, you'll be unwinding, say, you'll want to make a connection, for instance, with this red wire from here to here on your rather small circuit board. So you'll snip off a little piece, strip the ends, poke it into the headers, and go with that. And then when you're done, you unplug it and wire up something else. It's not going to be entirely about soldering everything together. A whole bunch of it is going to be in the form of semi-permanent patches with this little delicate wire. I say delicate, it's 22 gauge, it's pretty sturdy. Delicate in the sense if you need a magnifying glass or reading glasses to be able to see where you're poking it. And I intend to make stuff be available probably as JPEGs, like something like this when you have all the information sorted out. So it's a 4007, that is a dual complementary pair plus inverter. It's not going to necessarily say that. I'll probably write it in small letters under here. But what it will say is, this is a switch. You put a voltage here, and then these two parts get connected together or not. These pages, which will be like JPEGs, will say stuff like, this is a switch. This is an inverting amplifier. It can be a distortion box. This is a sequencer. When you put a voltage into here, it steps forward one, and the voltage from the input of it goes to another step along. And it goes through until it reaches the end, and then it starts over. This is the place where you put a voltage in to skip back to zero again, meaning that this is how you make it be a 4-step sequencer or a 5-step sequencer or anything like that. Because that's what these chips do. So PDF, not so much. JPEG, more like. And the other reason for making it in that form factor is I'm hoping to be able to have it so that you can have it on your phone. And it's 16 by 9, so it's sort of screen sized, but that's why it's fairly heavy lines and large letters, is so if you did have these on your phone, you could just sort of flip through them in any image viewer kind of thingy and open it up to show the thing that you needed and then be wiring it up while looking at that. So that's the basic idea. Is it's the world of patches. It's the world of patching stuff together and getting stuff working. Now here's where we were. We're going to save that for later because we're using really small prime numbers for this, and I was thinking about experimenting with that a little bit. We could do large numbers like these, but that would be so spaced out that our matrix reverb would stop sounding like a reverb. So I'm thinking, let's maybe steal the numbers from down here. And see what we get. Because I happen to have this list of prime numbers, which is what I was doing my delay times with before. Now we heard the previous build sounded kind of like a gong. This should be roughly the same, except for it'll be much broader and maybe just sound like a bunch of echoes at this stage. Let's find out. So the idea with the matrix reverb is that it's going to hang on to all of these things, but they're not forming into obnoxious comb filtery sounds. Like this builds up, but we've got it darkening here. But it is sustaining in a characteristic way. And something that we could do is use some of these other knobs. Let's rearrange that. We've had it at 100% sustain this entire time. So let's change that. All these controls still go 0 to 1. They're all still being enabled, so we have any of these available to use. So we're going to do what I was talking about the previous time and go in and actually update the comments and update the names. We're going to call parameter 4 regeneration because we're going to use that one now to do our sustain. And that means we'll define a variable. And divided by 2 is the same as times 0.5. So one of the things I can do here is build that into this. So now regen goes from zeros to get parameter kparam4 goes to 1. And if I multiply all of these by 0.5, that will give me the regeneration that is 100% regeneration again, because that's the value that we were using here. So instead of divided by 2, we're going to make all of these be times regen. And what that's going to do is let us control the sustain, which is we had not set up yet. I think one of the reasons I had it as divide 2 is because this is the same like word length shift gain thing. And if I change it from that, it'll no longer be as fun. One of the things I was also going to try was building this out of all pass filters and seeing what that gives me in a feedback matrix thing. And lastly, what I was going to do is add another delay and keep the pattern of the feedback matrix the same. What we're seeing here in this pattern is feedback is what the output is, and when we start, we're putting feedback times compress A, and remember we did compress A in such a way that we keep it from just blowing up and distorting. Compress A is usually 1, but we can make compress A be less than 1, so that is our compression on the output of the thing. And that's letting us give our infinite reverb kind of thing. However, if we're using regen, then these sounds will die away more quickly. And that's what I think we're going to demonstrate now. Throw that in here, go back to our little drum track, such as it is. No regeneration. But we can increase it. To infinite reverb. So this is what the matrix reverb sounds like. With these fairly slow delay taps. And they're also very closely linked. These are delay taps that are very similar to each other. And we have no vibrato in any of them yet. Although we can quickly get into a reverby-like thing by just pitch shifting them like mad. And this tells us interesting things about what natural reverb is like, because apparently it doesn't always hold perfect pitches. You can have pitch waver much like light wavers from heat. In fact, audio passing through hot and cold areas will shift its pitch, and that's how this works. That's how this creates this effect that it has. So there's one of our tricks right away, is throwing this pitch shift effect in here. And it's also darkening stuff at the same time. Whereas complete lack of pitch shift does this. So if we do this stuff, we start getting a kind of reverby sounding thing. Or we can have full regeneration this way. And this is a form of matrix reverb. Specifically, It's the householder algorithm for matrix reverb. We've got these different echoes. This thing that says interpol, meaning interpolate between delay tabs, is nothing but a digital echo. There's 4 different digital echoes, and they're all at their own different pitches. And what makes it be a matrix reverb is that the feedback, the sustain, all of the outputs of these little delays go into the inputs of all the other delays at the same time. That's what this area down here, feedback A, feedback B, feedback C, and feedback D, is doing. And we can see that what makes it the householder matrix is that if we're doing feedback A and it gets added back into the input again, you can see that each of these ones is feeding back its output at full volume back into itself, times regen, mind you. But when it says minus and then it's the other ones, all the other ones, what that's doing is that's giving us a feedback matrix in which each one gets its own output as feedback, and the output of all the other ones is inverse feedback, which would kind of cancel things out. We can also do a little quick test experiment. What would happen if we inverted that, which I think is going to break the household algorithm. But we'll find out, because this is about trying to see what happens. So now what we get is feedback is all of the other ones positive, and the one that it's getting fed back into itself is negative. And if I build that, I think I'll quickly find that it doesn't sound right anymore, or that it breaks in some way, because otherwise people will be talking about this as a good thing to do. Let's see. And remember, I have a bailout condition where it turns itself down if it's feeding back or distorting. We certainly get a loud noise out of here. But I gotta say, it doesn't sound bad. Maybe it'll sound bad when I don't. I think the deal there is that we're going to be hearing an annoying kind of flutteriness to it, and the other one does not have that. So you hear how it has this kind of rattly sound to it? Does not sound as much like a reverb, more like a bunch of annoying feedback loops. Whereas if we quick go back to the other kind, build that. One thing about doing the printed circuit boards is we'd never be able to do stuff like this, of just jamming on it and then hearing what it does. The printed circuit, although with solder core, with the actual soldering stuff together, you can. But if you have to construct printed circuit boards to make everything, there's a long delay between like sending your stuff out to get printed and getting it back and being able to try it out. This, on the other hand, a little quicker. Honestly, it does all kind of sound similar, though. So one thing I can do is quickly swap these. Oh. Go back to these very small numbers. Which were more like a gong, and do the same experiment. Except for now we have the regeneration control on it. So don't mind me glancing at the OBS and stuff, seeing whether I'm still actually broadcasting or not. So here's that nasty little gong sound. That was extremely unpleasant. Let's see whether it gets even more unpleasant when negating the feedback matrix, which is supposed to go a certain way. It might also have to do with the fact that I have this compression algorithm in here. And if this is the kind of thing that's set up to just sustain forever without needing to use the compression, then that would explain some of it. Benford Realness is not going to help you here. So this should sound worse. And it totally does. Okay. So here's how we work out what is good or bad as far as the householder matrix. We're not doing any vibrato, so we're stuck with the raw guts of it. And it's just a bunch of drones. It's honking really loud. And the previous one didn't do it nearly as bad as that. So what we're going to do is go back and then perhaps do some further experiments. Notably, the thing I wanted to experiment, and it's been an hour, so I might as well get ready to try this, adding another pole. Or adding another reverb tank, because you know the MV uses like 26 separate reverb taps at its full distance. And the idea of using a householder matrix is to be able to do a decent behaving reverb with much fewer. But I still feel as if you can expand it outwards, and I'm thinking of expanding it outwards in exactly the same way. So what I'm going to want to do is probably go in and deal with this stuff. Actually, I can do that much better. You can probably guess what I'm going to do. Except for nope, want the other way. That should target all these ones that I wanted to rename and make them be. And the reason I included int was to not catch weird random other stuff somewhere and cause problems for myself. I think the rest is going to behave, but I need to duplicate these a little bit more too. Actually, while I'm at it, fairly harmless to define stuff that you're not using in this experimenting phase. Might as well keep them even though. And let's see, we're going to J, and the count numbers are going to be the same. All right. So I just made space for a bunch of more variables to use as I see fit. And these go to J, E, F, G, H, I, J, E, F, G, H, I, J. And this is the kind of thing that people might do in arrays and stuff, but sometimes I like having it visible like this. And let's also make a nice little space between these two guys, and E, F, G, H, I, J. Now they are initialized. And we need to do the same thing here as we did before. So back into this, back into find and replace. And this time we're going to use another technology, which is replace all within selection. We're not defining it, so int isn't here anymore, but we still want to turn these all to count because they are all turned to count. So boop. And now that is up to speed with what we wanted. I have not decided whether to try to use the gong style well, let's sure. In fact, let's pick bad numbers so that we can space them more interestingly. Like, let's assume that what we don't want is stuff that's echoing like 2 times exactly in the space of 1 echo in a different bin, so they all need to be between 1/2 and 1 on a scale of 0 to 1. So we can have them all be within 0 to 1,000, since this is 800. So let's call that 1,000. We'll call that and these will interfere with each other, but right now I don't care about that. I just want to get this one introduced. I've also obliterated the number I had in there, but whatever. And now we're going to go in and duplicate some of this stuff. And go for a potential 5-way crossover matrix and see if it's nasty and unpleasant or not. And we're going to implement it exactly the same way. The thing that's helpful about having these arranged in the way that they are is that I can take all these mechanisms and just kind of make them add the new bin, because they're all following essentially the same rules. Oh, that's interesting. What are you doing here? I see a bug. Now, what are we doing with input sample here? Are we going to just redefine it somewhere? Yeah. Yeah, so I think this does nothing. Input sample, it does nothing. We're running this within console. That's what this does. We're putting input sample into the delay bank. These are the delay banks. This part is the same. We're changing the position of the delay banks. I'm damned if I can tell whether this does anything at all. Well, you know what we do then? Comment it out. See if it dies. It shouldn't. I don't think any of these relate to input sample up into the point where we're just calling it the output of these tanks. So technically, although we're not currently doing some of these things, this should still work. We're going to find out. Did I put back the... Yes, I put back the feedback. Did I remember to copy that over? Well, if I didn't, I have now. Here we go. So we've copied out those lines of code that seem to do nothing useful. We'll see whether that does anything. Now, the clanging we're hearing on this is, I think, part of why you space reverb taps properly. This sounds like an oil can. And that's because the delay taps are not set to prime numbers or something handy like that. Instead, they are set to just ratios. But we did establish that this did nothing. So we're leaving that out for the time being. Oh, and I see an awkwardness. It's not a big awkwardness. I've been counting from the opposite direction for some of these things, and so I'll need to offset everything by 1. See, what we have here is I can follow that same pattern and continue to be working with values that are hanging out there ready for me to be using them. But in so doing, I'm going to need to shift all of these guys over. So offset E, and then these are the ones that need to be shifted over. So Y, X, V, W, X, Y, Z. Because those were pretty much just kind of the same, but they're all running at a slightly different speed. Where do I set that speed? Vib speed, vib depth. Oh, yeah, there we go. So delay V, what do we even have there? Oh, that's just where I was getting numbers. That makes sense. So yeah, I just had these assigned to prime numbers, and I knew that they were stepping up slowly, but they weren't a huge difference between each other, and so I just used those. That will continue to work with this. It's just making them all have their different vibrato speeds. That's all that does. So not a problem there. And now we need to duplicate these into delay bank E this time. This is why I've got it arranged this way, so that I can see it fairly easy to comprehend. I just need to notice all these things, like that one here. I'm looking for that suffix, and this is why I do that naming convention. Is all the little variables that end in D, I'm like, aha, that is a variable that is associated with a bank of delays that I'm using. And so everywhere I see that capital D on the end of a variable, I might want to change it to something. If I miss it, then it will not act as expected. And it's visible rather than being like an array of some kind, so I have to keep track of the number or whatever. So there's the interpolation. Here's the feedback. But there is something special going on here. Here's where we do the householder delay matrix and see if we can expand it to 5. See, it's positive, the one that it relates to, and then all the other ones are continuing to be listed, but they are negative. So here I'm doing feedback B. I do need to continue to represent E in here up to a certain point. And this is the point. The last one adds all the other ones negative, and the one that it relates to it positive. So there we go. There is our delay tank, and we're also going to want to compress everything. So same deal with the compression stage. And again, like MV is using 26 things like this, so I haven't a lot of room for doing more. Some of these algorithms were worked out by very clever people back in the day when you had almost no CPU to do a reverb tank, like the Alesis and lexicons and things like that. I'm using Alesises, but lexicons are generally more well praised. And they had to do reverb algorithms in tiny, tiny spaces with almost no CPU at all. That said, it seems reasonable to me that you could expand that and go, well, if it works like this, then let's implement the same algorithm, but with 12 tanks instead of 4, because my computer can handle it, and see what we get. And in fact, that's literally what we're going to do right now, because I have just finished making the 5th tank. Although our tone is still going to be garbage. Maybe I should fix that. Using the 100 there is not helpful. So 1, 2, 3, 4, 5. Let's use the bottom 2, 7, 4, 9. They're fairly closely spaced, which is maybe not ideal, but 2, 4, 2, 3. And now we've just got this back again, so let's just edit that out and go from there. Now this should be either some kind of functioning householder reverb algorithm, or it doesn't extrapolate to 5 tanks without adjusting it. These are designed in such a way where if you're doing them properly, the feedback going through all the tanks has a particular quality where it's like a random number generator. It continues without ever quite repeating. And if it makes a nasty oil can sound, we'll know that that didn't work as expected. But for now, here is our 5 tanks of matrix verb. Oh hey, we have a result. That doesn't work right out of the box. Let's start fooling with it and find out what happened. We have our regeneration control, so we can dial everything down a hair. The idea of the matrix algorithm is that implemented properly, it will give you a sort of unity gain without necessarily adjusting the overall regeneration. But we can turn it down, so here's our problem. This is what you don't want. See, this is what you avoid. Although you can pitch shift your way out of it too. But that little feedbacky note, this is evidence that the 5-tank householder thing isn't working as expected. You got to do something else. We could, however, experiment by just... Oh, I thought I spotted a bug. I was wrong. Hey, Gemma. I got about 40 minutes left for coding before I should turn in for a bit. Do I have any more tea left? A little. So 5 sucked. Let's try 6. We'll go farther and farther from the truth. I also feel that that is a very typical reaction that one might get out of Chris. It's like, okay, I made all of these, so again, 5 sucked, so let's try 6, is how you sometimes get to different results rather than just going, oh, this didn't work, let's abandon everything and go back to the known. However, it is a little bit inconvenient that I've arranged it in the way that I did. But no matter. One thing about it, it's a different delay time, so we should be fine. And when I do the actual delay times, I'm going to be wanting to use prime numbers that are smaller. In fact, I probably should follow the experiment I was going to do in the first place, so let's do that. We've got this. Here's the feedback matrix that is not working because it is causing a ring. The householder matrix is thing that we're on is positive feedback, everything else is negative feedback, so maybe it's just requiring a little more doctoring. So 6 instead of 4. Now the bright side of doing stuff with things like arrays is you can just punch in a different number. The downside of doing that is that you can wind up with these large inefficient algorithms because you're not really keeping track of what you're doing. I'm not that worried about that though. And remember, that is only to deal with the vibrato, so technically I could not even be bothering with it right now. I'm just kind of, for the sake of habit, I'm kind of keeping everything within the same pattern that I understood it. But that stuff we're not actually using at the moment. Here's the heart of the algorithm. Remember to get that. It's not unthinkable to just do a find and replace on this, but I'm not terribly comfortable in doing a find and replace on literally a capital letter, in case it just turns up somewhere. I mean, I could, but I'm also fairly comfortable just typing really fast, so I fall back on that, and I feel like it saves me a certain amount of time and just not overthinking it. and F for this. And then same pattern, we're tacking this onto the end, except where it's already accounted for. As you can see, the matrix keeps getting larger. So yep, these are all accurately represented. Feedback E, A, B, C, D, no E and F, and then feedback F is going to be changed to E, and then that accounts for all of the feedback elements. What we don't know is whether it makes sense to do that at all. That's what I'm experimenting with. I want to see what happens. I want to see what I get. Maybe I'll get something that sounds amazing even if it's not technically correct. That's why I'm doing this. And let's fire up another compressed state, although I tell you, it wasn't actually helping us last time, so that's weird. So there's our output. This should build, and it should make a noise. We just don't know what kind of noise it's going to make because it could be equally horrible or worse. Let's find out. This is such an unpromising exploration that it's possible nobody's heard this yet. Let's find out what it does. And yep, that's a note, it's a feedback note. See, when the reverb matrix is not right, it can lead to stuff like this. And that's what you don't want. Although I will also say that if it's handled correctly, you could also say this sounds like a metal warehouse. We've got this note, and we're going to call that the sound of some shelf in there somewhere. However, it's clearly not helping us. Let's take it from there into a different zone. What I'm going to do is I'm going to jump on the web of the other place, and nobody's really chatting in chat so much, so I'm going to driven everybody away with matrix reverb. But I want to look up a list of prime numbers because I know the general region that I want them in. We have lots of space for them, all these very large reverb tanks, but we're doing A through F, so 6 tanks. So I'm actually looking for super prime numbers because I feel as if that's going to space them out a little bit more. So I've got a thing that says the subsequence of super prime numbers, it begins 3, 5, 11, 17, 31, 41. What I'm shooting for is probably a maximum delay of less than 1,000 samples so that they can be densely packed, but a minimum delay of more than half that, because there's no real benefit to any of the tanks being less than half the rate of the other tanks. They need to be spaced out in a certain way, but if there are multiple echoes for the duration of one of the longer echoes, that seems just not helpful. Not in this context. So what we want is a region where we could try this region here, like 401 to 537 or so, 447. So that's, I'm actually going to count upward this time. 431. $509. 47 and the idea is that these should space out the delay echoes so that we don't get those nasty rings or other types of effects. And there's another thing that I could explore as well, which is the public domain Reverb. Reverb is a batch of code, and one of the things it has in it is sample delay constants. Oh, I'm downloading it by mistake. That's not what I wanted to do. I just wanted to look it up online. Thank you. I'll deal with cleaning that up later. So tuning. You see, this is where things get useful. This fellow is using a set of tunings and arrived at a set of numbers that are actually kind of handy. So he's got comb filters and all-pass filters. The comb filters are going between 1,000 and 1,617. That's exactly what I was talking about as far as what we needed from this. And we've got 8 different things. So I guess what we're going to do is we'll try to make a matrix reverb out of the timing constants from Reverb. He's also got all passes. The all passes are shorter, and he's only got 4 of the all passes, but we've got 8 of these constants. So clearly, you see what we have to do here. We're going to add another 2 delay bins, and we're going to do it this way. So 1, 6, 1, 7. We'll count down again this time. 1, 5, 5, 7. I don't know if these are necessarily primes. I could look it up, or somebody in chat can look it up if you want. I'm not terribly concerned because they are the Reverb numbers, and we're going to see whether that does anything useful. This is public domain code, so you're allowed to use these numbers. 1, 4, 2, 2. I believe they were arrived at by ear. 3, 5, 6. It's neat to me that it follows the conditions that I specified. I told you, it needs to be not exactly between the range of 0.5 and 1. So if 1617 was 1, then the bottom one is not even close to 0.5. So they're occupying a kind of spread that will cover a range. And while I'm at it, I'm gonna also write down because, you know, we could punch these into the original matrix reverb and see what that does. That could be interesting. 41, 41, and although the all passes are not actually, and each of these have a additional value which is 23, which is of course another prime, and that is called stereo spread. So all of these, one of the filters, for one of the stereo channels is this set of numbers, and then you've got stereo spread added to all the right channel ones, and those are all a little bit slower, up to and including the all passes. So I'll make a note of that too. And all of these numbers, you add 23 to get the stereo version. That is... Hey, Bo. Yeah, you caught me busy working on a thing. So. Oh, and I'm not surprised nobody's showing up. I did not announce this anywhere. Well, anybody who wanted to drop by, there's just our little thing now. So let's see, we're all the way up to H. 8 different stereo tanks. Although we could quickly want to do the experiment of seeing what the all passes would be like. I think we could do this fairly easily. I bet I can. But I am going to want to keep these. So. So that is now the original one. Some of these things we don't have to worry about. We can leave them calculating. The machine's not dying, so it doesn't matter if we calculate them as long as we're not using them. In fact, we can calculate all of these things except for these have to take away this stuff. So we're not doing that, and we're saving this, and we're taking these out. And that gives us back our original feedback matrix. The other things are not touching our original stuff because we've got them all commented out. These extra things don't matter, so we can still calculate them, and this does matter, so we're not going to be listening to the output of the other ones. And that should have our original household matrix back. So compared to that terrifying high-frequency ring out of the 5-stage householder matrix, we should be back to something that behaves a little more normally now. Or not so much. Yeah, it turns out the parameters for the all passes are not that useful. We do have our householder matrix. I think we do. I'm trying to remember whether that got broken somehow. I don't think it would have. In any case, that's hot garbage. So we're using this. The householder matrix is correctly arranged. We're not using any of the other stuff, so it's harmless. It's not doing anything. Well, I'll tell you what. let's just take this right out and go directly to only the 4 top Reverb things, and we'll see whether this behaves itself any better. Maybe we're getting a characteristic Reverb sound out of some of this. I'm trying to remember whether the all passes in Reverb are in series. But it does feel a little bit like if we're getting that, then it's probably not helpful. This is the same thing, but spaced out a little more. Ah, see. We're not getting aggressive feedback notes now. I mean, it's not great, but I wouldn't call that terrible. It's not ringing at any particular frequency. It's acting a little white noisy. So this is the householder matrix in action again. It's kind of sustaining the sounds without being too atrocious. But we weren't done with this stuff yet. Oh no. We had tried 5 and found that they sucked. We had set up 8. Now we're going to try the householder matrix set up with 8, which means I got to duplicate all this over again a little bit more. This is the pattern we're going to want. And that'll give us 8 banks. Maybe it's just me, but I do find it somewhat more understandable laid out in this kind of way. It's a lot of space on the page, I'll admit, but you can plainly see what is being done. And then, let's see, same pattern with this. Add 2 more. So now we have that. That is still the same as it was. And with this, let's see. ST. I've done a lot of that stuff. One of the reasons I have it alphabetical like that is so that I can kind of be thinking about something else while trying to make the code test my theory. I'd much rather be pondering some complete other thing rather than like, this is how I construct the thing. Makes very little difference to me if it is time-consuming and tedious looking on the page if I'm thinking about something completely else and are not being distracted from thinking about something completely else. So, energies. It does wind up being a little tedious, I admit, but then sometimes my head is working on some concept around it where my attention is going to be elsewhere, and the crudeness of it is something that I can generally wrap my head around even when I'm very distracted. I'm not unique in this, by the way. The other people have done this kind of thing. Notably, John Carmack and other notable game coder had a conflict at one point where other notable game coder, Jonathan, somebody, I'm distracted, was reading Carmack's code as the Quake code came out or whatever, and was very upset because he was like, he has done this inefficiently. And then he later decided, well, he's done this inefficiently because he's trying to focus on something entirely else, and that's why that's happened. So it was a bit of a learning exercise for that fella. But there's room for all kinds of things. All right, 2 more of these and expand the matrix. Oh, or 2 parallel householder makers, seeing as we have multiple sets here. That's a possibility. But first, let's set it up. Alrighty. This is going to be a little messy, but maybe we can do it. We're almost certainly not going to want this. But in a sense we do, because I want to hear what it sounds like. All right, so up to D, we're good. E, F, G, H, F, E, G, H, yep. G, E, F, H, and H, E, F, G. See, it's missing the one in the beginning of the algorithm. And having done that, now I need to play a little of this too. And now, let's see what terribleness we have wrought. This could be awful. We're going to find out whether this is awful and should never be done. Or maybe we'll go into a new plane where we've discovered a noise that nobody's ever made before. But we're going to find out. Dun dun. I'm guessing it's going to be awful. But there is another possibility I can try if this is sufficiently horrifying. Oh yeah. Yeah, we out of control here. This is bad. See, what's happening with this, the way it's arranged, when we have these notes feeding back like this, it reduces the ability to do anything else. We can't get that long sustainy thing going on because we just get this. And when we tamp it down so hard that that's not happening any longer, we have no sense of sustaining reverb at all. Although if we completely kill it, we do at least have a sense of what the immediate delay taps sound like. And the immediate delay taps are more or less okay. But yeah, that obviously ain't working. So let's see what we can do. We can keep the large output of all the input samples together. Let's take this apart and make it into two separate feedback networks. So you see what I mean with that? It could be profitable to work out what a big complicated network like this could be with yeah, remember how I was going to experiment with some of these things? I'm going to take the ones from the opposing networks and throw those in there and see what I get. This is a hunch. It's probably not going to amount to anything. But what I was going to do was make them two separate little householder networks, and that would presumably work because they wouldn't really be communicating with each other unless I made them communicate with each other, and that would be interesting too. But if I have this and then the other four, I'm sort of changing the pattern. So F, G, I want to steal G out of this one. There is no specific reason for me trying this, other than I'm trying this. And we will see what we get. Straightening it out as best I can. G, H. So I'm going to want to steal H out of this one. And as you can see, what I'm doing is they're kind of mirroring each other in that the 1 and the 5 are linked, and the 2 and the 6, so on. So I'm changing the way these are arranged. And let's see, I'm going to want to steal interpol B out of this one. And C out of this one. And then lastly, D out of this one. Okay, and this is no longer a householder matrix, but it has some points of similarity. It contains a householder matrix within itself, but it's also containing these other positive poles. I don't know what this is going to do, but we're about to find out because I'm going to try it. I feel like the sheer number of negative poles was perhaps causing the problem, and if I manipulate it in this way, then we actually have the same number of positive and negative poles that the original householder matrix had. And a moment of truth, let's see what we got. Well, we do have a ring. Gotta love those horrible noises. What happens when we vibrato that up here? Yeah, we're getting the feedback issues. So this is not doing the thing that a house order matrix does, which is be able to do this almost like full regeneration thing without freaking out. So next thing that we try is it's 12:54. I want to do something interesting before I log off for the day. Although this has been a nice little productive session with fooling with this stuff, is run this as two separate distinct householder networks. And if that works, I can experiment with swapping one element of each of them to see what that does. Or having them bleed into each other in some way. So firstly, let's see whether I can do a massive undo of a lot of this stuff. There, we've got that back. I think this is the easiest one to manipulate, so see, householder matrix. EFGH, and then the other in the little 4-element cluster, it's negative the opposite of the one that's positive. The missing ones in the collection are the ones that get put in as negative. And now we just simply delete all of these out of here. D, ABC, C, ABD, B, ACD, A, BCD. This is now two parallel householder networks that are not communicating with each other. We're essentially running two simultaneous reverbs, all with slightly different delay times. Let's see what we got. This should work. If it does, I'll swap two of the elements and I'll see where that takes us. Because that might be just the thing. Or it might not, for all we know. Boom. So that's what a delay matrix does. It's a way of doing feedback where we have this sort of dense sound going on. Notice we're not having to do any vibrato at all. No vibrato in there whatsoever. But it's still making a pretty dense audio. And even taking it fairly close to the delay, it does still decay, it does still fade away. And none of our high frequencies standing there are turning into feedback squeals. Also, you notice when you start taking the regeneration way down, it really goes away very quickly. It's all about being able to manage the delay behavior, the reverb behavior, when regeneration is almost complete and still not like squeal or go into a feedback noise like that. So we've demonstrated that the two household matrices work. Last experiment is this. we're swapping these two elements. Now the two feedback matrices talk to each other. But they're still inherently, in fact, they're not only inherently still householder matrices, but the element that I'm swapping is in the same position on each of the matrices. It's the first one in the setup. This might work. Or if this doesn't work, we can have this be interpol A plus E divided by 2. We'll merge them together, and that might do something as well. That's the next try, I think. And I think I'll keep hacking on this until we've been able to try that. But for now, here is the two matrices bleeding into each other concept. And if you had 3 householder matrices, a total of 12 delay taps, you could have them bleed into each other in a sort of ring. And that could also be interesting. But for now, let's see what it is like with them bleeding into each other directly. We have a problem. Well, the funny thing is, when it's not actually feeding back and blowing up, this doesn't sound half bad. Well, it sounds kind of bad. Yeah, that feedback note is no bueno. We're going to back that change out, or rather, we're going to produce something else. You know something? I was going to do this in the matrix. Maybe I shouldn't be doing this in the matrix. Maybe I should be doing this here, before the matrix. Param 5 is now blend. Now I can dial this in. Whoa. There we go. That'll hold us for now. So param 5. Now we're generating these, but what we're going to do is, and I suppose I could try to steal a different, I haven't tried all of my possibilities yet. We'll leave that there for the time being, but let's find out what happens if instead of swapping with E, let's swap with F, see what we get. They're at slightly different positions. I suspect it's going to give us the same thing, but I'm not certain. We'll find out soon enough. So does this also have horrible high feedback note? Yep. Yep, having those feedback in directly into each other is no good. But we might still have something we can do. So put this back. In this condition, it's fine. It's two distinct and separate householder feedback networks. Will it blend? Or find out where it's going to blend. Might as well just use E. You're recognize this formulation because it looks exactly the same as the way I do dry wets. And we're also going to do the converse and bleed E into A. It won't make it perfect that way, but at least that'll be a sort of parity. They'll both leak into each other. And let's now see, after adding some semicolons, so it'll compile, let's now see what we made. This should go from normal to super duper broken, but on a slider. And that will be some form of interesting anyways. Oh, didn't mean to do that. Come on, you. Yeah, how about you remove from sidebar, please? Thank you. All right. Final experiment for the day. Matrix verb. That's two householder matrices. Interesting. We're definitely hearing that feedback in there. It's not supposed to be favoring notes like this. Got a sort of metallic quality going on. And of course the way this works is I can actually reverse the two. Let's do a quick little hack on this. What do we get if instead of blend being a number, blend is 1 minus the raw value of regen? Then if regen is at full up, there's no blend, but as I start dialing it back, it starts bringing in this weird ugly characteristic. And also, what if I was doing it on all of the banks rather than just the one? A question that is much on my mind. Let's find out. There, now we have blend being 1 minus what regen is. So if regen is full crank, no blend, otherwise it starts bleeding its way in. Let's have a quick gander at what that sounds like. Because if I'm doing two distinct householder delay matrices, I really want to make them talk to each other or affect each other in some way. That seems like a far, far better thing than just running them in parallel. It kind of sounds a little bit like something's going on here. We get a sort of steel room thing going on. This could be a snare room. is at least able to avoid going into those feedback noises at these high ranges. Oh, and doing it this way, I'm getting a certain amount of like high glittery reverb tone. Yeah, we've got a damping control that is like a bass trap. It's giving us a glass room reverb. I'm hearing all that cymbal stuff more than I otherwise would. Well, one of the things about that is that if I use vibrato in here, it'll start damping down the highs enormously. So let's fool with that a bit. Interesting. So what have we here? And then dial it back to let the highs in. This is an interesting balance. Yeah, I think I got one more experiment to do. And it's always that way, isn't it? I'm like, I need to go and rest, I need to go and make lunch, but then I'm cranking away trying other things. So the one thing I have remaining is, if blending these worked, let's blend all the other ones too. I'll set them in pairs like that, because they are being pairs. They're being pairs being swapped. So B, F, C, G, and lastly, D, H, D, H. Alrighty, that does the same thing as the previous one did. And the previous one did something useful, so we're going to find out whether this, extrapolating it in this way. Oh, I should put back this though. I can leave it at 1 minus, but I want separate control over that. I want to see what it does. So let's try that. Build components. Matrix verb has to be 1 to be a full crank. So there's our pure householder. Kind of gritty. Yeah, I'm not convinced this is desirable. Full regeneration and we're still having this behave, kind of. Kind of drony. Drony is not great. Although it's producing a drony, obnoxious sound, but it's not going into overwhelming feedback. Or rather, when it does go into overwhelming feedback, yeah, not convinced. I wonder. It's really making them ring in a characteristic way. What the heck, let's see what it sounds like as it was before. Now, is this better or worse than what I just heard a few minutes ago? I gotta say, I'm not as convinced by this one. I think crossing over all of the 4 sets was overkill. I sure am getting a lot of brightness out of it, though. Let's do halvesies. I was interested in seeing where that would take me, and that took me too far. So we'll do A, E, and C and G, and not these other two. Another possibility is to do a different pattern. I don't know. I think that the way this is working... Oh, heck, let's just try it. So the whole deal with this is bringing up this nasty metallic quality that's also coloring and change. Because the thing is, we can define that the accurate householder matrix is correct. And we can define that, like, okay, we can do perfect uncolored reverb matrix sound. And then maybe run it through filters or something like that afterwards. But if we have a way of making the reverb broken in such a way that it adds a distinct sound, that's useful. And I think we may be getting in the zone. Drum room. Glass room. This totally becomes like a bright ambience. It's hanging onto that hat really hard compared to this. Yeah. And it's hanging on to a lot of that brightness, though. Let's fool with something else. These need to cross over between each other, but that doesn't mean that... Let's cross over with different ones each time. B and A to E, E to B, C to G, G to D, I guess it would be. I have no idea what could be expected out of this, but we're going to find out. Because the 1 crossover was good, and the 4 crossovers was far too bright and unpleasant. And this is just doctoring it in a hitherto unknown way. Because the people that calculate this stuff out would never do this. What do we got? That's actually kind of plausible. It's sure hanging on to that highs. And let's bring in a little of that reverb. Regeneration is going to have to be readjusted so that there's a much wider range of motion, but that's easy, that's trivial. Or I could map the vibrato speed to the regeneration. See him kind of matching the move? Whee! Yeah, let's try that. That seems fun. Vibrato speed, map to regeneration backwardly. Oh, wait. No, I guess that's right. I guess that's right. This is how we start dialing in a sound that is made out of a composite sound, where it sounds like you're manipulating something that's more organic because a lot of things are getting involved. Vibrato depth is still a separate thing. See how many things we've got writing off of parameter 4 there? This is either going to work super or it's going to be terrible. But if it works properly, it's scaling it. Oh, didn't do that right. And this is why I forgot to do this. Boop. Anyway, I know nobody's asking any questions or anything, so that's fine. I will be finished. I've run a half hour longer than I was expecting. But that's all. As maybe I'm on the track of something. We're going to see where we get. Nope, that works. This is the full sustain area. And the usable range is in the middle, so it seems about right. We could have vibrato depth be always a little bit on, if that helps. If it's allowed to go all the way off, that means we get this bright zone. Which is very intense. Oh, those cymbals. Let's crank the depth all the way up. Okay, it's starting to sound like we have a interesting possible reverb going on in here. Bypass. It's definitely kind of freaky, but we might have something. Heavy pitch bend in there. We could smooth out that vibrato depth a little bit too, by the same method. Maybe it doesn't need quite as much as that, but we'll see. And then I'm going to fire up something other than this drum track. See where we get. Or another possibility is to send the sounds into each other through an all-pass. I don't know though, I'm not sure if that's the way. Yeah, and then we get some crazy pitch bendy. That's spacey as hell. Yeah, I have a feeling that space ambiences are going to work with this one. Maybe we'll call it Space Verb. Bright, shiny verb. We've got that no vibrato full brightness behavior. We can bring in some bright vibrato. And it darkens right up. Yeah. Seems pretty good. Let's throw it on a track from Dragons, like Wood Dragon. What can we get as far as a Washa sound? sounds like enough fun for now. Not sure if that's the best choice for fooling with that one. Do I have anything which would be better as a choice for fooling with that one? Probably not. Drag something out of this one, maybe. Okay. Didn't expect that. Uh-huh. That's coming from this. Oh dear. Yeah, this is pretty strange. Alrighty then. I think that's enough madness for now. Going like 45 minutes past what I was planning to do, but we made Matrix Verb into a something. And we're running two parallel Matrix reverbs, two householder reverbs, and feeding them back into each other. So there might be more fooling with this later, but for now, I'm going to call that a day. And I will see you folks later. And take care. Catch you later. I'll probably do some kind of music thing on Thursday or something. See ya.